Hello, everyone. Good afternoon or good morning, depending on where you are, to the 2021 version of Consortech Awards of FME Excellence. My name is François Lagagnère. I am one of the partner and the guy responsible for business development at Consortech. I was a very, very slight part of the jury. It was mostly our technical team that had the tough job to evaluate all the projects we have received. We received almost like 20 projects, which were all, of course, great projects. But like we had to, in fact, the jury members, they had to do some heartbreaking choices in selecting the winner in the three distinct categories, which are the best small efficiency boost. Sorry about that. Sorry, best small efficiency boosting project, the best automation project, and also the best out of the box project. What we, in fact, like since like we received like so many interesting projects, what we did, we of course selected like the three winners, which will do the like a presentation today. But we also had some special mention for projects that were still very, very good, at least to mention. And what we will do, we will in our next newsletter that will be released by the end of the week, we will describe all the the winners project and also the special mention with some information on why like those projects were selected instead of others. So today, like each presenter or each winner will have approximately like 15 minutes to do the presentation. Then we will have like a 3-4 minutes Q&A. I will manage the Q&A, so you can use like the chat box to send the question. Depending on also like the question we will have, you will have the opportunity to unmute your mic to ask questions to the presenter. So we will start by the first, the first category, like the best small efficiency boosting project. The winners are the city of Sacramento, California. Today they will be it will be Ryan Kirkham and Crystal Fenef who will do the presentation. Just before I pass the mic to Ryan and Crystal, just to mention the special mention to the city of Victoriaville, Quebec. They used FME to publish an interactive map that allows citizens and other city stakeholders to access information relating to zoning and land use. Once again, more info will follow on the newsletter. So on that, Ryan, you have like you have the mic, if I can say.
Great, thank you. My name is Ryan Kirkham. I'm a GIS specialist with the City of Sacramento, Department of Utilities. I've been there for about 8 years, and let's see, I wanted to say just a special thank you to Consortech and to SAFE for hosting and putting all this on and for the selection. So we really appreciate it. Share the screen. So our project was a water sampling application. So we just called it, for this presentation, it's simplified sampling. The city of Sacramento, they conduct daily water sampling throughout the city along, my co-presenter here is Crystal Fenef. Crystal, did you want to say a few minutes or just say hello?
Hi, my name is Crystal Fenef. I work in the city of Sacramento. I've been there for almost 3 years. I was on the Department of Utilities GIS team. Currently, I'm on the architecture team. And I just, assisted Ryan with this project, setting up the AGOl integration. So thank you.
Thanks, Crystal. So to set the stage a little bit for our project, the Department of Utilities, our water system, consists of about 145,000 connections. We serve about 500,000 people. There's about 160 miles of transmission mains and 1,500 miles of distribution mains. We have 2 treatment plants, 12 reservoirs, and 28 permitted potable wells. So it's a pretty large system. We serve a lot of people, and to serve a group that large, We have to do a lot of sampling to make sure that we're conforming to all state and federal regulations, and that we're just providing the best product that we can to our ratepayers. The sampling that occurs out in the distribution system every day is completed by 4 full-time water quality lab technicians. And they will go out and schedule these samplings at about, we have about 256 possible fixed locations out in the system where they'll go out and do their selections or do their sampling. So that could be at a spigot at the front of a house or at an actual piece of infrastructure that's been built off of one of the pipes. And then once they collect all this information, they're coming back into the lab, and we're storing it in a laboratory information system, which I'll just refer to as LIMS from here on out. And LIMS is actually just an acronym that's kind of it's general for these databases. It's not the actual product name itself. So about early in 2019, our water quality group approached us and asked if there was a way that we could make the process that they were currently doing a little bit more efficient. And, when we asked them to kind of go over what they were doing, it was essentially all paper-based at the time. And so what they would do is in the morning, they would go into the LIMS system. They would schedule the samplings that they were going to do. And then they would print out forms and take those out on a clipboard, do their sampling, record everything and take their samples back, and then hand enter that all into LIMS when they got back in the afternoon, whenever they had finished their sampling. So this, as you can imagine, this would introduce a lot of potential for manual data errors. It was extremely time consuming, and they knew that there probably had to be a better way to do this. So after we sat and talked with them, after Crystal and I sat and talked to them quite a few times, we decided to go with Collector for ArcGIS and to use FME to be the glue between our on-premise and cloud systems. And this project was broken up into essentially kind of 3 pieces. So there's the generating the work orders in LIMS and then pushing them up to ArcGIS Online. The folks who go out in the field with an iPad and collecting the data in ArcGIS Collector. And then the action of actually pulling that and pushing that data from ArcGIS Online back into the LIMS system automatically. So these were just some of our challenges that we kind of encountered at the beginning. To be honest, I was kind of hesitant to take this on at the very beginning, because when you're talking about things that are, related to water quality or that have chain of custody requirements, it can be a little daunting. But it actually wasn't too bad once we started talking to them. Our biggest problem, or one of the biggest problems, was at the time, our GIS system did not expose any of our web services outside the firewall. So we had to come up with a way to kind of circumvent that, because we had been told by our network team that that was essentially just not going to happen at the time. And we just weren't ready for it. We had some ArcGIS Online account procurement issues during the project that set us back for a little bit of time. The way that we typically procure these accounts, we like to procure them all at the same time so that we're not getting constant bills from ESRI at different times of the year. We just like to do it all in one shot. The LIMS during this project, they actually changed the LIMS database from Access to SQL Server. And so that was actually really helpful, but also a real big challenge, because we went from being, the Access being really easy to having to get DBAs involved and create new accounts and manage that in just a much better ways. But overall, it was a challenge, but it was also kind of a blessing too at the very end. We had lots of schema differences between the LIMS system and what GIS was managing. From data types to just length of fields, lots of different things like that were in there that we had to deal with at the time. Our biggest problem, or at least the one that took the longest to solve, was the data that was actually in the LIMS system. In many cases, we couldn't sync to anything that we had in GIS, because the 2 data sets had lived separately for so long and had never been integrated before that, getting the right sampling location ID to sync up, getting the right locations together, making sure that we were kind of, that we were collected when we would run tests, that the right data was getting associated to the right location, and that all of that could be stored correctly in the LIMS system. And then the upload, one of the requirements from the users was that they wanted the uploads and downloads to be user initiated. So they wanted the power to be able to do those at any kind of given time that they wanted. And so we kind of settled with them on allowing them to do one singular upload in the mornings to push all of their known work orders up. And then the downloads could be initiated at any interval, anytime by any of the users that had gone out in the field and collected stuff. And then finally, there were some date and time issues, like there typically are, going between different systems and working between UTC time and local times. Not to mention that LIMS only stored an actual date field and then a time field. So we had to keep splitting and managing these date values and making sure that that was being managed moving forward. So this is just a screenshot of the workspace for pushing from LIMS to ArcGIS Online. It's very, very simple. We tried to keep it very, very simple. We worked a lot with the subject matter expert on the LIMS side, who was very familiar with all of his data and their database and how to kind of put that all together, what they needed to push out. So I relied on him to write a lot of the SQL code that he needed and just execute that from the SQL executor, which was really, really efficient. And that data gets pulled and then pushed up into ArcGIS Online once in the morning. And the fields with the little small kind of white arrows next to it are the only ones that are populated on the push. Everything else is collected in collector. And then we had to, as I was talking about earlier, with some of the schema, interesting schema differences, as you can see under the LIMS field, things called like order details underscore user 0, 1, 2, 3, and 4. Those were actually the values that they're collecting out in the field. So, trying to keep those, in line back and forth was kind of a challenge sometimes because, when I look at database fields, when they have the user 0, 1, 2, 3, 4, those are always kind of it's easy to get those mixed up. So Crystal, why don't you handle this section for the GIS stuff and just let me know when you want me to keep going.
Change slides.
Yeah.
All right, thanks, Ryan. So as Ryan said, we worked really closely with the LIMS team. And first, we just worked with them to develop a schema that was going to be used in AGOl to, be basically the inspection form in the field. And so this inspection form, how we related it back to the sampling location. So we had the feature layer was a sampling site, which, as Ryan said, we had in GIS. But some of the fields weren't matching into LIMS, so we had to do a lot of data manipulation with that to kind of, get those aligned. But what we also did was add the facility ID. So we have a facility ID for all of our sites, and we added that field to the LIMS database. And that way it was able to push that as well. And so we were able to use that to relate the new inspection form, the inspection table, to the sampling site GIS data. And so when the FME would pull that, it would pull that facility ID also and be able to relate it back in the LIMS system. So really just creating that schema, it did take quite a bit of time, just to get the schema. And once we got the schema and the sampling locations, what we did is we created a feature database or a file geo database in just on-prem, and create a relationship class within that file geo database between the table and the feature layer. And then from Pro, we published to AGOl as a hosted feature layer and a related table. And so for the red map, the user wanted to be able to easily see what sites needed to be inspected and what ones had not yet been inspected. So to do this, we also added the feature layer and the table to the map, to a web map, and then we used the analysis tool within the web map to perform a join features analysis. And so since the table wasn't spatially, had no spatial data to it, we used matching features or matching fields between the two tables. So we used that facility ID in the table basically to create a join within the web map. And we did a one to many, so like many inspections to one sample site. And so when we created the join feature, we created it as a hosted feature layer view. So that is also nice because it doesn't consume any credits in AGOl. Now once we had that hosted feature layer view, we added that to the map 2 times to symbolize and filter by, if there was a date in the date field of the inspection form, that meant that that site had already been inspected. If there was no date in the inspection form, then that meant it had not yet been inspected. And so we kind of used that filter to be able to symbolize between, those two situations. So let's see. Another thing we had to do was, we hosted or published this feature layer as having full editing privileges enabled, but we only wanted the user to edit the table and not the sampling sites. So just to make sure that they only edited the table, the inspection table, we turned off editing within the web map and turned off editing for the feature layer in the web map and enabled editing on the related table. So once that web map was created with all of the editing privileges set and the symbology set, we were pretty much ready to go. We just created an inspection group and added all the users that are going to be out in the field with the iPads to that group. And then just made sure it worked in the collector app, and we were pretty set. Ryan, if you go to the next slide. This is an example of that join features analysis. I'm not sure how many people have used that before within a web map. So you can just select, your layer and then what you want to join to that layer, and then you can choose the fields to match, and the one to many, and then you can name it. And again, at the bottom, if you select create results as hosted feature layer view, it doesn't consume any credits. If you can go next slide, Ryan. And so this is just a screenshot of the map. I kind of took it just one random morning last week, so there was only one sample to be collected down in the bottom left of the city. But you can kind of see, how we, added the multiple layers and put the completed and the samples to be completed over the sample sites. So the sample sites are kind of just as a reference. So they can see, all the sites that are out there. And then you can go to the next slide, Ryan. So this is screenshots of how it looks in Collector. The user logs into Collector, selects the map, opens the map. They see and zoom into their location, or I think in Collector, if you're out in the field, it might just automatically zoom to where you are. And so then you would tap that location and it would open the second screen, which shows you the related table, the samples for collection. And so you could then just click view. And so when you view it, it shows you on that next screen, the 2 samples that need to be collected. And then you would tap that little box with the arrow, which means you want to edit it. And then you would go to the next screen, which would take you to basically all the fields. For the collector field, we did add like a list within the hosted feature layer so that it has all of the inspector names. So they don't have to go through and type their names. The date collected is like, shows a calendar, so they don't have to go in and type. And yeah, I think that's pretty much it for the AGOl side. Ryan, if you want to take it on the next slide.
Great, thanks, Crystal. So once the users in the field are finished collecting their data, each one of them can take, a lot of different, much different time than the other. So depending on how far out into the city they have to go. So when they come back to the office, they can they log into FME server and they just run this one workspace that pulls data from ArcGIS Online to LIMS. So it reaches out and grabs the data that we put in. This attribute manager is where we manage all the date time issues that I had mentioned before, where we have to split it and then put it into two different fields and then try to account for UTC time. Then it runs a test for if the collect date is null or not. So this is where it's filtering out anything where there has been a collection or not. So if it's null and it fails because there is a date present, then it pushes it to this database updater where it just matches up based on the facility, on the sample number that's been collected, and then it updates all the records that are in there. And the nice thing about this is that no matter when the person comes in from the field or who it is, whenever they run it, all it's doing is updating the data that's currently there already. So we're not overwriting anything that needs to stay. And it's pretty seamless, and the staff really seem to like it because it's super, super simple, and that's what they wanted. So let's see, it's been in production now since about January 2020. We implemented it kind of just at the right time before COVID. And they've been completely unimpacted by a lot of this. Like, we haven't had to take anything down or do a lot of on-the-fly changes. The only thing that we have to do is change a flag for UTC time every time around for daylight savings time. So initially, when they had reached out to the group that produces the LIMS software, it was originally going to be about between $15,000 and $20,000 for a mobile license, and then about $2,000 a year in maintenance costs. And so we've kind of eliminated that, and the only cost has been the 4 iPads and the 4 ArcGIS Online accounts. That's the only cost moving forward. There's also been a huge amount of reduced errors, and we really improved the data quality, which has made using their own data much, much easier for them, and being able to report it and put it on dashboards and have other people see their data, so that typically, historically, they have not been able to do that or put that data out there for easy use. For us, the biggest thing was this really built a level of trust and confidence with this particular user group. And with the success of this, they actually came back to us to help build other add-on applications like this Chlorine-Residual Spatial Dashboard that we put together. And so as we continue they only wanted to start with chlorine residual and see how everything went. And so there's 4 other values in there that they're going to start collecting, that we're going to start putting into this dashboard at a later date. But like I said, this really helped build a lot of trust and confidence with our user groups, which is really key to getting us involved with other groups as well. So this is a screenshot of the chlorine residual dashboard that we currently use. Anytime there's a water quality incident, this gives the staff a really easy way to go, look at where the incident occurred, and then look to see if there's been any kind of spikes or things that would cause any concern for that might be the cause for some of those calls. So our future plans right now is at the end of the year, we're looking to try to move to ArcGIS field maps instead of collector. We're going to take that slow. It shouldn't be too big of a deal. And then hopefully we can utilize some arcade scripting inside ArcGIS Online to simplify how we do the symbology on the map. Instead of having to create 3 different layers, we might be able to do it with just 1. So we're investigating that, and hopefully on my end, I'm hoping that I can find a better solution for some of the UTC issues that we've encountered. So yeah, that's what we're looking to do in the future.
Well, thank you for, oh, sorry about that.
That's right. And then just one of my last ones here. My quote from the project was our main person from the LIM side. At one point when we were going through and cleaning and fixing all of the data, he said, his statement was, "Man, Ryan, you found all the skeletons in my data." And that was a really, it was funny, but it was also really great because it, again, helps build confidence between the systems and for the city in general when, sharing this data with folks. So yeah, that's it. Thank you. And
Excellent.
I'll turn it over to you, Francois.
Okay, thank you, Ryan and Crystal. Since we are running a tight schedule, we won't have time to ask questions, but there are like 2 questions in the chat. So if you want to answer them, either Ryan or Crystal, feel free to do it. On my end, I just want to mention that first of all, as I was saying, it's a great presentation. And for us, the jury found that the conceptual simplicity of the 2 bidirectional workspaces between LIMS and collector via ArcGIS Online, it was really at the heart of the decision. Also, that the solution we think that it can inspire a large number of municipalities, organizations wishing to streamline the information gathering process in the field. Of course, all in line with the spirit of simplicity and efficiency of this category. So to follow up, the next winner is the City of Toronto in the category of Best Automation Projects. Just before I pass along the mic, sorry about that, to Vailin Lau of Toronto. Just want to mention that the City of Richmond Hill, they were the special mention. They used FME as to create an enterprise asset management tool. It was large scope project. They use FME in a more traditional way, but the scope of the project was really large. And they also impressed the jury by enabling the city to save 50% of the capital cost of creating that type of solution, and they were reinvesting that money in the quality of data. So it goes a bit with also Ryan, what you were saying. It is of course important to put emphasis on data quality, and FME usually allows that. So Vailin, the mic is to you.
Great, thank you, Francois. Hi, my name is Vailin. I work for the City of Toronto in the City Planning Division. I'm a supervisor in the Graphics and Visualization Unit under Urban Design. So I was actually inspired by this project by attending one of the FME conferences a few years ago, and I learned about the possibility of using automation to produce photographic maps. I thought I would apply the same concept to the development review process report maps that we prepare for Community Council. So 2 years ago, it started off with me putting together a workspace as a proof of concept. It turned into a pilot project, and with the support and training from Consortech, we've been fully operating this project since the beginning of this year. The part of our workload in graphics and visualization is heavily focused on creating report graphics for the development review process. It's a report prepared by city planning staff where it reviews the developer's proposal, and these proposals can range from the change of use of land, subdividing the land, and developing a new building on the land. At the end of the report is where we come in. It is a series of graphics shown on to help facilitate the development review process. Depending on the report, we would have to prepare 4 to 10 graphics, and there are typically 5 standard maps that we will have to prepare manually using ArcGIS and Illustrator. So in a month, we create about 300 report graphics, and that translates to a lot of hours for our staff to prepare. So very quickly, these maps that we typically prepare are the key map, location map, the official plan, land use map, and the 2 zoning bylaw maps. So as mentioned, we use ArcMap to create the report graphics. We have templates set up for each report graphics, which staff open, locate, create the polygon of the subject site, and the image shown on the screen is an example of the location map template. We've also created a customized Python tool to help staff create the subject site where users select the parcels of the subject site, And to help enhance the metadata, we have staff input information such as the application number, which is a unique ID, the address, the application type, the submission dates, and the description of the development proposal. So all this information is actually entered in manually by the user, and it's of course, which introduces errors and not quite an efficient way to enter that information. So all this information gets input into a geo database, which is a collection of polygons showing the development application. So once finished creating the subject site polygon, the layout is reviewed to ensure that the text and labels on the map is readable. If not, it's then exported to Adobe Illustrator for any text adjustments and then export to a raster image. The graphics are submitted to the planner once it's prepared and finished, and this whole process is a manual process, but like I said, it's an outdated workflow and honestly not quite an efficient use of staff time for having to spend hours to prepare. But this is where FME comes in, to automate this whole process and to modernize the creation of the report graphics. I know it's a little hard to see the images because it's quite a long workflow, but the workflow itself is made of two workbenches, the initial application workspace and the cartography workspace. Both combined workbenches have over 500 transformers, and of course, due to the interest of time, I'm just going to summarize how both workbenches work. If you're interested, of course, in a further more detailed walkthrough of the workflow, you can always contact me, and I'm happy to provide that information. So I'll first talk about the initial application workspace. The first part of the workspace begins by gathering all the information we have about the development application in the form of a customized Excel sheet that we retrieve from a website form. So we can download an Excel sheet about the development application through a customized date range. Here's an example of that Excel sheet. So this is showing the submitted development applications for the week. It's the same information that we've inputted into the ArcGIS tool to create the polygon subject site. So when I run this initial application workspace, it will take all the information from the Excel sheet and process it through automatically. So to create the polygon of the subject site, it relies on the addresses that we have on that Excel sheet. So since each development application has that unique ID number associated to it, we can group all the addresses based on that unique ID and then intersect them with the parcels to create our polygons. Afterwards, the polygons are then updated to that geodatabase. Once that subject site is created, it gets processed through the cartography workbench through a workspace runner. This workbench creates all the cartography of the report graphics, and I'll go through this in a little bit more detail later. After the workflow runs through the cartography workspace runner, we have a folder and file naming convention designed that uses the unique application number and the address to create the parent folders, as you can see on the left image. And on the right is all the files that were, or all the maps that were created inside those folders. Once all the folders and report graphics are created, an HTML report is created to summarize the whole process to determine which development application went through, as well as we've implemented quality checks on the report graphics to see whether any revisions to the maps are needed, or any revisions to any of the development applications are needed as well. All right, moving on to the cartography workspace. As the name implies, it's the creation of those 5 standard report maps. And as a reminder, that is the location map, the key map, the 2 zoning bylaw maps, and the official plan land use map. And once again, I'll break that into parts. So taking that polygon of the subject site that we've created from the initial application workbench, we rotate and center the subject site so that the subject site is always in the middle of the map. Depending on the area size of the subject site, we use that to accommodate the different map scales. So for example, for area sizes of 25,000 square meters or less, we will have a map scale of around 1 to 5,000. 25,000 to 70,000 will have a map scale of 1 to 9,000, and anything over would have a 12,000 map scale. So this scale is also used to clip the data so that only data within the map contents are shown. After setting the scale of the maps, the next part involves gathering all the data from various sources and filtering out only what's needed to minimize the amount of data read. So this would include GIS data from our SC geodatabase. So that would be like the parcels, addresses, buildings, etc., stuff like that. Zoning bylaw, like AutoCAD data, and any images and text that are used to create the layout of the map. For map labeling, we use the map TextLabeller transformer, which is a separate plugin created by Safe Software. It handles the labeling on the map quite well. It's not always perfect, but if there's any text adjustments, we can always edit them through Illustrator to ensure the information is readable. For the more complex maps, such as the zoning bylaw and the official plan land use map, we have a dynamic legend. So whatever information is shown on the map The legend items will also show those map items. So after all that information is filtered and gathered, the data is clipped using the scale boundary created from earlier. It is then passed into a PDF page formatter transformer. So since there are 5 standard report maps, each map has its own PDF page formatter, and the objects within the PDF page format transformer is designed to have the exact same look as the ones we have from our ArcMap layouts. So the most difficult part of the PDF page format is that there's no alignment option, and the positioning of the objects in the layout was quite difficult to implement. So you'll notice that on the image on the left, that the legend item and the address title is positioned at the very bottom left corner. And so depending on the amount of legend items and the length of the address title, that box will have to resize based on the format that we implemented, so that it will be positioned correctly on the layout. The last part of the workspace is to perform quality checks on the map layout. So there are limitations on the amount of information that can be placed on the map layout itself. So simple quality checks, such as if the address title is too long or goes off the page, a revised text will be implemented onto the file name so that whoever is working on the files will know that something will need to be revised manually. Another quality check that we implemented is the dynamic legend. So once again, if the dynamic legend is too long or goes off the page, a revised text will be indicated on that file name. So I've tried to incorporate as many quality checks into the workflow to fix automatically, but sometimes really just human interaction is just needed for visual edits and checks, and we do that in Illustrator. Oh, once all the quality checks are performed, all the maps are written out as a PDF, and the last thing that needs to be done is to have staff quality assure and control the report maps. That follows our map standards. So the image you see on the screen is a how-to document for staff to follow to ensure maps are to its standards. And well, to summarize, well, there's no more long hours of producing these maps manually, as we now have a fully automated workflow that takes only 5 minutes to run and creates all sets of report maps. At the moment, we're currently running the workflow weekly, and it's producing an average of 78 report maps a week. That's a lot of time saved for us, and we can focus our efforts on working on other projects. There's still some things that we need to be done, and we eventually want to implement a landscape version of the report maps. We don't have a licensed FME server yet, but we would eventually transition this workflow to FME server so that we can do the workflow automatically. And lastly, we would be exploring and applying the same automation approach to other projects. I also want to give a big thank you to Consortech, especially Leslie, who was the one that was coaching and training me and FME and providing support on the automation workflow. She especially helped me on a dynamic legend, the mathematical formula for the PDF page formatter, and teaching me how to use private and public parameters effectively. And I'm not just saying this because they're hosting this session, but there's so much benefits in the services that they provide, and they help me think outside the box and solving difficult scenarios, and overall improve my myself as an FME user. And that's it. I just want to thank you, everyone, and I hope you guys learned something new. And I hope you guys have any. Does anyone have any questions?
Thank you, Valen. First of all, yeah, like you did receive some help from Leslie, but like all the idea comes from you. So it is first of all, like just to mention that like your project was selected because there's a complexity side of the selection. So like the workspace, of course, are quite complex, but really what made the difference is the fact that your project pushes the limit of FME in the field of using cartography. So it is, to us at least, in the eyes of our expert, is quite uncommon. So that's why like you won the award. So once again, congratulations. Do I have? Yeah, I see a comment from David that a lot of other municipalities would benefit from this. Absolutely, and also that's a point where it's a point that is taken into consideration, the general interest for the whole FME community, especially for municipalities. So I don't see other questions. So anyways, like we're right on time. We have like 20 minutes to go. So we will finish with the last category, but not the least, the best out-of-the-box project. The great winner is the city of Terrebonne in Quebec. And just before I pass the mic to Lucie Boucher from Terrebonne, just want to mention the special mention to Hydro-Quebec. They used FME in a structure inspection project. In fact, they used FME to do comparison of point clouds with FME. So in that specific case, the jury was quite impressed by this unusual and ingenious use of FME. So Lucy, your turn now to present your project.
All right, so you should see my screen. Does it work?
Yeah, it is.
All right, so I'm going to present to you our FME portal. So, okay. So my name is Lucie Boucher. I'm from the city of Terrebonne, and I've worked on this project and presentation with my colleague Patrice Marseille. So a quick word about Terrebonne. We're the 10th biggest city in Quebec. Our population is over 117,000, area 158 square feet. And our geomatic department is quite young. It was created in 2016, and we're now a team of 5. And hopefully we should be 8 by the end of the year. So what is the FME portal? Well, in brief, it's a French front-end interface for FME server. It was designed to be user-friendly and to minimize the number of clicks. It's responsive, and it can be used by field workers or by external partners, consultants, etc. So where did the idea come from? Well, first, we were part of some projects for which we consider using classic mobile mapping applications such as Collector or Survey123. And to use those apps, we had to buy several expensive user accounts. And sometimes when you have to buy 100, 150 of those accounts, well, the cost for those licenses was completely disproportionate in comparison for the benefits of the project. And therefore, we had a few projects that were aborted, and that gave us a low agility reputation, which really bugged us. And also, we realized that some users who have access to our internal web map application, they find it too complex to use. They have access to all the data and tools to perform analysis and extractions, but no matter how many times we explain to them how to proceed, no matter how many tutorials we provide, they just won't use it because it's too complex for them. And instead, well, every time they have a need, well, they place a request to the geomatic department, and that creates a burden on our team and it generates delays. So we had the feeling that we could improve things with FME server, but we still had an issue. The interface is only available in English, and in Quebec, the law forces us to provide French interfaces to our employees. So we brainstormed about that, and we came up with the idea of some kind of web portal to access the script. So Patrice and I, we worked on the functional analysis, and we gave well, a task to Tran from Consortech to build something out of it. And this is what came as the portal. So it's a simple web page, web app. You have to log in, of course, and once you log, you have this blue section at the top with categories or topics. And every time you click on a topic, you see under it that you have access to a series of tasks. And once you click on a task, you have a form, and you can fill the form and click on the launch button, and it sends a request to FME server. So everything is responsive, of course, as you can see. And what we have to say about the architecture is that our FME server, our databases, everything is still protected by the firewall. The only element that is in the DMZ is the portal. And the content of the portal is directly linked to what we have in our FME server. So for example, on the left side, I have the FME server for interface for a repository, and you see the name of the repository is exactly the same name under the little sewer here. You see that I have had a little bracket here specifying an icon. That icon ends up to be my little sewer icon here. The text is directly related, and the content also is identical. And the permissions also are managed through FME server. So if a user has access to a repository, he will see the category in the FME portal. If he does not have access, well, the icon and the scripts will be invisible for him. And then Tran has worked a lot on the workspace parameters to really simplify the forms. So the first thing, if you want your workspace to appear on the portal, you have to go in the workspace parameters in the overview section and add this little application bracket. And as soon as you do that, the workspace will be available on the portal. Sometimes you don't want that. For example, if you have a parent workspace and a child workspace, it would be useless to have the child workspace visible on the FME portal. So you would just avoid that little application bracket. You can also add a little icon bracket here to specify which image you want. We have this test bracket in order to use the test database or production database. And you can write a description that will appear once you display the form. In the forms, we can use most standard parameters. So for example, if you specify a number parameter, you can use a lot of configurations such as range, insert a default value. We can have some date time parameters, and in the form we will have access to that little calendar to pick the date easily. Also, you can see those little red stars beside the parameter name. They indicate if a parameter is not optional. So if you forget to fill one of those fields and you press the launch button, you will get this little warning here showing that, you forgot something. Then we started to work with Tran on advanced parameters. So the first one, we wanted to be able to fill drop-down menus from a table in our database. So basically, Tran has managed to, for us to be able to add some detailed brackets here in the workspace parameter. And with this, this bracket, you can specify which table and which attribute will be queried. And the result of that query will fill the drop-down menu. And there's also a possibility to use the selection of a drop-down menu to build a where clause for the second drop-down menu, so to have some cascade menus. Also, we have drop-down menus that can be built from SDE domains. So we have Enterprise Geodatabase from ESRI. We use a lot of domains, and we wanted to be able to use those domains and return both the code and the value to the workspace. We've had geometry pickers. So in the forms, we can specify, in the workspace, we can specify which background map we want to use, if the geometry will be simple or single or multiple, and the type of geometry. And there's this little map here that will display. We have some file upload parameters. So with that, we can specify the allowed file types and the maximum size of the files, and the user can drag and drop the files, and you see the little red box here showing that the transfer is done or has not worked. Finally, a lot of our workspaces return something to the user, either an image or an Excel spreadsheet or something through email, or will send email notification if there was an error. And we didn't want our user to have to tape their email every time they use the portal. So Tran has worked something. We had this little tag here as a default value in the text field, a text parameter, and the user email will be set as a default value. So now I'm going to go with a few examples of how we use our portal. The first one is the summer. We have a lot of street sweepers working around in the streets of the city. And we made a few scripts for the foreman to be able to indicate where the sweepers will go next, what are the sectors that have some cleaning operation plan, and to change the status also to say that, to mention that a sector has been cleaned, that is completed. And so they have those scripts, and every time they update the data, we have a web map available for our citizens that show that, for example, this sector here was cleaned last week, or the other one will be next week, etc. We had also a request from our communication department. Often they receive emails from citizens with pictures indicating, showing a problem, for example, a broken fence or something. And they wanted to be able to locate that problem on a small map. So we gave them a little form. They drag and drop the picture. And if the picture has embedded coordinates, we return a small JPEG map with the position of the picture, and they can insert that in an email or a report or anything. Also, we have a truck traveling through all of our streets and taking cap images for our ImageBail's mobile mapping application. And we want to know daily what streets have been captured. So we gave our consultant a little form here, and daily he drags and drops some KMZ files, we update a map, and we see what streets have been done. And we can calculate some statistics also on that. What else? Update data in JMap. So unfortunately, updating data in JMap is a low priority task in our team. We have too many projects to work on. And so sometimes we have users that send us data to update in JMap, and it takes several days. So where we want to go with that is basically a form where the user will be able to drag and drop the file, and we will directly call JMap's API and send an email a few minutes later to the user to confirm that the data was updated. We'll go from several days to a 5-minute project. Snow removal on ice rinks. That's one of the projects that was canceled initially and gave us that low agility reputation. What we want to do is give an access to our foreman so they can indicate that the ice rink in a specific park as is its snow removed or not, and so the citizens can go and skate. So a simple form again that will update a web map available to citizens. Number of electors. So every time there's a new zoning bylaw, the citizens might have to vote to accept or not that bylaw, and the city needs to know how many electors might show up. So they wanted 2 tools. The first one, they select a city district, and the other one, they select a zone from our urban planning zones. And once they do, they launch the application, they receive an email with the number of electors. Upcoming development in that specific tool, we want to be able to do some multiple choices here, because sometimes the bylaw will touch, I don't know, 10, 15 zones, and we don't want the user to launch the application 15 times. Going quickly here, mailing list. So the communications department, they want to send letters to citizens, so they draw a little surface here, fill a few questions, and receive an Excel spreadsheet with the addresses to send the letters. So the benefits of our FME portal, well, users are independent. It's really easy to use. So it reduces the delays, and it reduces the burden on the geomatic team. We maximize the use of FME server. We have jobs that can be submitted from outside. So consultants, partners, field workers, etc. They can all launch tasks on FME server. We have access to unlimited accounts for free. So buying user accounts is no longer an issue for a project. But of course, we foresee that we will need to add some engines to our FME server. The portal is really simple to use, so even for our geomatic team. So we even consider moving our own workspaces to the portal because it's just really interesting to use. We've inserted quality control here and there in the workspaces that we've deployed. So quality control is always a good thing. And future plans. I'm not going to go through all of them. Graphical uniformity. Right now, our icons have been taken from free websites here and there. So we want to work a little on the graphic. We have a log table that indicates who has launched a task from the FME portal, and was it a success or a failure. So we want to do a little analysis on that, maybe a dashboard. We have lots of other workspaces that we want to deploy, some CAD checker, some click, zip, and ship. We want to work on our JMap update a lot. So a lot of work coming from that portal. And in conclusion, I just want to thank Consortech for considering our portal worth of the Outside the Box prize. So thank you.
It is a great pleasure, Lucy. And as I'm sure like all the attendees were able to evaluate like the originality of the I'm saying like the clever use of FME server. First of all, like to make your project elastic, that allows like to democratize the use of FME. Of course, like publish different workspaces in workspaces and functionalities and targeting like different also city departments. And also, I'm not sure if you mentioned it, but like on different platforms like tablet, phones, laptops, of course, computer. And to finish, also, as you mentioned, Lucy, it significantly reduces the need to purchase field licenses and this expensive named user. So it's really in the spirit of this out-of-the-box category. So we do have a few minutes left. I know there was like one interesting question with regards to the server apps, the FME server apps. So I don't know, Lucy or Patrice, if you want to answer, like any thoughts about using FME server apps and the app galleries?
I'm not very familiar with FME server apps, but I'm pretty sure it's only available in English.
Yes.
So it would not solve my problem of providing a French interface to my users.
You are right. And it is also less elastic, as I was saying. Of course, like your project has like a great scope. Once again, it's why it won the category. So I don't know if there are any other questions. Could be to Lucy, Vaylin, or Ryan and Crystal.
I see that Patrice has answered David's question in the chat.
Yeah, and in fact, like some of the answers of previously asked questions are in the chat, especially the one with regards to Sacramento's presentation. So we are a minute before 2 o'clock. So I want to thank first of all, like all the winners, and also all the of the other organizations that have submitted a project for the awards. For sure, there will be a 2022 edition. So we will just announce it at the beginning of next year, so at the beginning of 2022. But if you want to share what like your work, please feel free to do so. And once again, thank you all for submitting, and also thank you for attending this presentation. And I wish you a great rest of your day and a great rest of the FME World Fair. Bye bye now.